Thank you. And I want to thank the assembled team there for the opportunity to address you today. It was my intent to be there face to face. That was not meant to be, but again, thank you for your time, and I look forward to the dialogue afterwards. We believe here at CESMII that there is an urgent need for a national smart manufacturing plan. We've been advocating for that. We've been working towards that end, but there is much that needs to be done to help drive us in that direction. And our comments today, reflective of the Institute, the members that we represent, hopefully will help move in that direction. I thought I'd start with what I believe is one of the most important and clear images of the challenges we face in this space. This is what last week, what Paul Boris was referring to as well. I've been watching this trend now for about 3 years, looking regularly at the Federal Reserve data set from Fred, from the St. Louis Fed, and hoping that this productivity, U.S. manufacturing productivity by employed persons would begin to reverse, but that obviously has not happened. And in fact, in the period of time coincident with the fourth industrial revolution, we've seen for the first time in recorded history that manufacturing productivity here in the U.S. has first plateaued and declined. I did some analysis recently to try to understand why that's the case. There's plenty of opinions about that. Many of them very nuanced, but I think one of them is that one of the reasons that we see this is that access to free money, essentially zero interest rate access to loans, caused manufacturers to invest in more creative financial vehicles, which obviously distracted them from investing in operations. And that said, I did some further work to see as best as I could how manufacturing investment in automation would lay over this curve. And I could go back about 20 years with the data that I found. And what I found is actually fascinating. Capital investment in automation mirrors this curve almost perfectly, at least up to 2021. Meaning that for the decade of the 90s actually and early 2000s, manufacturing investment in automation grew commensurate with this productivity curve, and roughly in 2010, 9 and 10, manufacturing and automation here in the U.S. plateaued, and I think that is clearly an important outcome or analysis that underscores the need for us to continue. I think there are also some other important reasons that we'll discuss here over the next few minutes. I thought I'd just state maybe the obvious for the group assembled here in terms of the challenges that we face in the U.S. here in terms of manufacturing and our goal to drive manufacturing productivity. I think the continued decline that I've just tried to articulate as underscored by the fact that smart manufacturing, digital transformation is happening at an accelerated rate in Europe and Asia and is essentially stalling here in the US. That's cause for grave concern. Supply chains across this country, particularly between large manufacturers and their small, medium suppliers, rely fundamentally on emails, phone calls, faxes still, believe it or not, to detect and address potential disruptions. Shocking to contemplate that, but it's true. Growing productivity gaps between large and small and medium manufacturers. There's a digital divide, and I think that's has huge implications if we can't address that. Workforce poorly equipped to engage in the innovation and value creation process. It's going to speaks to the availability of technology on the front lines and more innovation that's required on the front lines. And then last but not least, growing complexity, cost, and failures of digital transformation. And that's ultimately what Kevin from McKinsey was addressing as well, or at least identifying. So at the dawn of the fourth industrial revolution, it's clear that we're clearly still a very disjointed and noisy ecosystem. we're all vying for relevance, trying to create value, but manufacturers are overwhelmed by the noise, and particularly that's the case for small and medium manufacturers. It's important for us we believe, to collaborate much more effectively to bring a more unified, more cohesive, and compelling approach to smart manufacturing. I was intrigued by the data that Kevin brought to us this morning, back to his comments about pilot purgatory. I think understanding the adoption friction for scaled digital transformation is one of the most important things we can do. And I think that's where I would say CESMII has been laser focused for a number of years now. And it's really about a couple of important realities. And I hope this doesn't sound harsh, but I think it's important to be candid about where we stand. There's a remarkably primitive understanding still of the complexities of manufacturing systems and how data can be used to support plant, corporate, and supply chain strategies. And incidentally, I think this is why OT and IT still struggle to get along, to engage. But that's a conversion. That's a conversation I think we'll leave for another day. Because of that, though, most of the technology providers, implementers, consultants, and educators are led to assume that what they've built, what they've implemented and accomplished in one manufacturing setting just automatically translates and is relevant to all other manufacturers. Unfortunately, that's not the case, or rarely the case, which is why we're seeing U.S. smart manufacturing deployment stall, AKA pilot purgatory. Any honest observer is going to come to the same conclusion. We need urgent new ways to understand, or urgently need new ways to understand and address these complexities, the technical debt of our third industrial revolution approach, and work to accelerate our ability to improve our competitiveness. I thought I'd share kind of a 60-second walkthrough of some of the underlying complexities that I think most folks don't get to see in their day-to-day work. This is what we use in engaging with our stakeholder groups here at CESMII to help them understand at a macro level how to best avoid this pilot purgatory and become more educated in this space. This is perhaps a little on the geeky side, if you can bear with me, but I hope it helps convey how important it is to understand these complexities. If we're going to develop strategies that truly accelerate adoption, I think that's important. So we did some significant analysis a number of years ago and looking at all manufacturing industries, resulting in a few really fundamental observations, almost at the first principle level. The result was this 3x3 grid representing 9 fundamental production types. We see discrete, hybrid, and continuous process on one side, one axis, and make to stock, make to order, and engineer to order on the other, resulting in essentially 9 production types, each of them with unique business processes and rules. This has major implications for how we think about data and explains how we've reached the extraordinary level of cost and complexity in the manufacturing systems world that we're trying to reform and transform today. So that said, there are also some implications in terms of data sources, connectivity, and automation that have really significant implications. When we think about machine tools, CNCs, lathes, that's essentially in the sort of discrete engineer to order and some of the make to order spaces. In the rest of the sort of discrete world, you'll see a preponderance of PLC-based automation, and of course that extends into the make to order in a significant way as well. On the continuous process side, we have distributed control systems, and then moving into sort of a blend in a hybrid world of DCS and PLCs. And so it's important to recognize that for each of these 9 production types, that there are very distinct automation and control strategies in each of these boxes. And this gets a little more technical in the context of how we architect smart manufacturing solutions. Manufacturing context and resulting data ingestion strategies and application infrastructure vary by production type as well. In the continuous process world, time is by far the most important source of context. In the discrete world, time is almost irrelevant as context. It's about part ID, batch number, vehicle identification number, shift number, operator ID, et cetera. It's very transactional data versus time series data, which is what you'll find in the process world. And this too has significant implications. And this is kind of where the rubber hits the road. As we map out by industry where individual manufacturing plants or where industries fit in this matrix, we can see perhaps for the first time why we've created a world where every application, every use case is its own data silo, is its own stovepipe architecture. This is, for example, where the aerospace industry fits. And another example, automotive assembly is largely focused on these four manufacturing types or production types. The automotive supplier world fits into all six of these boxes. Any individual manufacturer is likely in one box, but when you look at automotive supply in general, you're going to find that many of them fit in each of these individual six boxes. And here's the epiphany. Manufacturing applications, no matter what type, almost without exception, when they're born in one of these boxes, they rarely, without significant cost and complexity, can be used in another box. And so we find that in our effort to standardize across our manufacturing plants and our enterprise, even within a business unit, there's a huge cost and complexity in trying to do that. And this is essentially why, that because of the workflows and business processes, the production schedules that look radically different from one production type to the next, it's really, really complex to scale from one manufacturing type to another. And so approach here has been to recognize those complexities and do what we can to enable innovation across every manufacturing type and ensure that we can bring to bear sort of an ecosystem approach to solving the problems that we are mandated to solve. We see our core mandates from our funding agency, the Department of Energy, here in the top left. Our execution strategy is to accelerate the democratization of smart manufacturing. That's essentially our word or our approach to reduce cost and complexity. We do that in the domains of technology, enabling interoperability and decreasing cost and complexity of manufacturing systems and technologies, in the realm of knowledge, and of course, in the convening of an ecosystem around these problems and how we can work more collaboratively to address what has historically been very, very proprietary approaches to data, to networks, to systems, to automation, and to manufacturing architectures. So, of course, we've developed our roadmap. We've updated that consistently as an institute, and as Mike Rinker alluded to yesterday, we've been very systematic in our approach to defining and working with manufacturers around these first principles of smart manufacturing, with sort of this virtuous circle here of first principles, starting with interoperability and openness, sustainable, energy efficient, secure, scalable, resilient and orchestrated, flat and real time, and of course, proactive and semi-autonomous. This is kind of a one double click on our strategy before I move on. The first of these initiatives or these approaches is taking more of an end-to-end look for specific industry use cases that are representative of our strategic goals to the Department of Energy or for the Department of Energy, and to do the R&D necessary to solve these use cases as industry exemplars. The second segment here, or second approach, second area of investment, is to address some of the fundamental technology architecture and ecosystem challenges I've highlighted in the previous slides. We need a new interoperable and open approach to enable innovation on a whole new scale. So together with our membership, we've created a smart manufacturing specification at the edge, at the sort of core data ingestion and contextualization layer, and then at the interface layer with an open interface for modern apps using modern IT-friendly development constructs to build applications, smart manufacturing apps. And then we built our own implementation of these specifications using member technology and are demonstrating for the first time that we really can cut the cost and time to implement smart manufacturing by 50%. And in the third pillar here, last but not least, we've been investing to contribute practical training assessments like our smart manufacturing business assessment, our smart manufacturing journey road mapping tools, et cetera, for industry to leverage and to benefit from. And this is also part of our talent investment for community colleges, trade schools, and of course, universities in this domain of smart manufacturing, hoping to create tighter partnerships between industry, academia, and of course, the broader ecosystem. And a big part of that is as you see at the bottom here, these smart manufacturing innovation centers. We have 7 of we call SMICs, these innovation centers, predominantly at key manufacturing centric universities where these technologies, these education, this ecosystem approach comes to life, engaging with the marketplace in very tangible and practical ways. So I think it's important to kind of reflect on how we accomplish our overarching objective of making the U.S. a more competitive manufacturing environment. If we look at the manufacturing landscape, I think it's been noted a few times over the last couple of weeks that we have a lot of manufacturers in this country that are in the, I'll call it the tiny realm. Roughly 76% of the manufacturers are in the sort of 50 employee and above range. And really, ironically, it's 1.66% of manufacturers that make up the Fortune 500 ecosystem. And yet with my background, my 35-year career in the space, it's probably of note to articulate that coming from Rockwell Automation, coming from GE, coming from a software startup built to focus on enterprise manufacturing intelligence, I have never intentionally called on a small, medium manufacturer. Almost this entire ecosystem is aimed at the Fortune 1000. So I mentioned this digital divide before. Unless we can convene this ecosystem together with policy and support from the federal government to ensure that we transform the work we do in a way that points at the small, medium manufacturers and not just pay lip service to it, which is where most of these Fortune 1000 industry providers, technology providers, and implementers and consultants are focused today. Unabashedly, that's the way their business models are structured. This digital divide will not be threaded, will not be crossed by the small, medium manufacturing community. And so I think to underscore that, it's really less than 2% of the marketplace that virtually every technology provider, implementer, and consultant is focused on today. What CESMII is chartered to do, to accomplish, requires a new approach to how data is used to create value. From sensors to networks to automation to data ingestion architectures to the applications that transform data into value to business model transformation to cultural transformation. This kind of disruption has historically taken decades. We're over a decade into the fourth industrial revolution and need to recognize that we're still largely stuck in doing business the way we have been for the last 40 years of the third industrial revolution. So in working with our membership, we concluded that there are some important things that we can do to accelerate this transformation. You may have heard in the last couple of weeks of the formation of the Smart Manufacturing Executive Council. I was thrilled to work with both some of the organizing committee as well as Jim Davis and Janine Coons to bring this Smart Manufacturing Executive Council to this initiative next week through a 1-hour session, 60 or 90-minute session. That's the intended purpose of this new Smart Manufacturing Executive Council, chartered to develop credible, practical strategies and policy recommendations to dramatically improve manufacturing productivity here in the U.S. Hopefully you can see on this slide here the 4 core pillars of our charter. to demonstrate leadership from folks who are at the pinnacle of this journey, inspire the ecosystem to evolve their strategies and business models, to provide guidance for each stakeholder group in this ecosystem, and to inform U.S. policymakers on the transformative actions and policies that will accelerate U.S. adoption of smart manufacturing. Just to give you a sense of who they are, they're mostly Fortune 500 manufacturers, and I'll comment on that in a moment, but there are 3 small and medium manufacturers. And the way we're organized with that sort of approach, it's an unfortunate reality, but a reality nonetheless, that the market-making technology providers, consulting organizations, implementers, machine builders are, as I mentioned, are clearly focused on serving the Fortune 500. But that said, if we can create a framework and a way of innovation and doing business in this new sort of approach to democratizing smart manufacturing that helps the big manufacturers, where we can simultaneously reduce the barrier of entry for small and medium manufacturers, which is, we believe, how we're going to drive transformation and help cross that digital divide. We've been working on the frameworks, the technologies, the tools, the education that will reduce that barrier, that reduces complexity, which is what the large manufacturers are after, and structured in a way that we believe and are completely confident will help small, medium manufacturers get engaged in smart manufacturing for the first time. Our initial goal with this executive council is to create and publish an authoritative smart manufacturing guiding principles document. It's a role-centric set of strategies, recommendations, and learnings for each stakeholder group that you see identified here, and that they believe are essential for smart manufacturing success. I thought it was particularly, we've had our inaugural call 3 weeks ago with this executive council. I thought it was particularly interesting that there was complete consensus that this guiding principles document needed to encompass strategies for small and medium manufacturers to ensure that the large manufacturers are engaging proactively with the small, medium manufacturers in their supply chain, which is in general over 95% of their suppliers are small, medium manufacturers, and to ensure that they're not left behind on this smart manufacturing journey. So before I summarize with my specific recommendations for this initiative, I thought I'd close with this slide to say, in the same way that the 5 I articulated these 5 as the top areas of struggle and challenge for smart manufacturing and the catalyst for a need for this plan for smart manufacturing. We're excited at CESMII to be focused on directly impacting each of these individual challenges, these areas of opportunity for smart manufacturing. This is how we believe we can address this ecosystem and work together with the federal government, with policymakers, with academia, with every one of these stakeholder groups to impact the change that we know is necessary. In no particular order, and I was asked to call out sort of medium-term priorities from short-term priorities. I think they're all short-term priorities, but I did take the step of delineating between those that I think have a better chance of being executed or acted on quickly versus those that are perhaps more comprehensive and need time to make their way through our system. Like I said, in no order of solve here, federal funding to support stackable smart manufacturing credentialing programs for small and medium manufacturers and for large, but particularly for the citizen technologists that we believe is so essential for small and medium manufacturers. And subsequent to that, a large-scale national education program to create and roll out a citizen technologist designation and capability. So every small and medium manufacturer, even those that don't have specifically IT and engineering staff accessible, can still engage in smart manufacturing. This is the outcome of reducing complexity so that they can actually engage without hiring a new type of worker in their organization. Next, investing in a standards-based national supply chain data interchange, allowing all manufacturers of any size to securely exchange vital information about manufacturing operations in real time. Lots to dig into there, but we believe this is essential. Amplify and dramatically increase Manufacturing USA's visibility in the industrial marketplace. I shared a couple of weeks ago that in a room full of 100 US manufacturers, 95 of them will have heard of Industry 4.0. One or two of them will have heard of Manufacturing USA and of CESMII. We're doing our best to change that, but that's the reality. Next, fund the convening of the ecosystem to build standards-based information models and AI machine learning models and data sharing infrastructure per the previous conversation and per the outcome of the AI machine learning workshop that Jim Davis and Bruce have been working on, and many others there have been working on for a long time. Europe is doing a stellar job of this. We're working closely with our counterparts there, the platform Industry 4.0, with VDMA, the largest manufacturing association. VDMA, actually in partnership with CESMII, is right now convening over 600 machine builders and technology providers to do this. And virtually none of them are from the US. We have a great model. We have the opportunity to leapfrog them right now with the work that we're doing here at CESMII, the profile work, information model standardization, the work to drive interoperability into our manufacturing architecture.
Sorry for interrupting. This is actually a very interesting slide. We want to have some discussions about this. So, so we have about 10 minutes left. If you could quickly wrap it up so we can have some discussions.
Well, I can wrap it right there. I think if I can leave this slide up.
Let's do that.
For others to read. Okay, sure.
Okay, thank you. So do we have, okay, so we need to regroup, right? Any questions for John in terms of one of those recommendations?
There were questions earlier from Slido. I'll read one, and that says, when you say standardization efforts fail, does this relate to information content in the standards or content format type or broadly semantics interoperability? Also related question is, it fails because of cost of implementation of standards?
Great set of questions. So standardization efforts have failed on multiple levels. Let me address them briefly. Number one, standards in general have seen very little adoption in this smart manufacturing domain. I think that one of the few that has gained traction is OPC, the OPC Foundation, and their approach to connectivity. But other than that, even ISA 95 has seen limited traction. B2MML, the organizations that are PACML, the organizations out there that have been working on structuring semantic structuring of data and building models have not seen broad adoption. And it gets back to the sort of 9 production types that I mentioned before. But I think the main outcome of that is that across those 9 production types, when you take an automotive assembly plant, for example, that one plant encompasses make to stock, make to order, hybrid make to stop, and hybrid make to order, and yet based on our learning that an application that fits well in one of those boxes does not automatically or simply, and in some cases at all, translate to other manufacturing types. It becomes very, very difficult to take even one product, one asset management product, or one predictive maintenance product, or one quality solution, and use it across more than any one of those production types. So that's where efforts to build manufacturing strategies and smart manufacturing strategies result in pilot purgatory. The complexities in moving across multiple different production types has made it almost unscalable for those types of standardization efforts. Standardization on a vendor or on a solution stack.
So maybe a follow-up question on this one, also related to the previous question, whether we have kind of, image, right? Like an ImageNet is some kind of, similar things for smart manufacturing, for benchmarking, for people can test out different AI tools. So in CESMII, have you seen people raise that need? And whether if so, is there any kind of plan in the future to implement something like this?
Yeah,
because I would think that consortium, right, is a perfect platform for doing something like this.
Yeah, if there's one of the smart manufacturing first principles, if there's one at the pinnacle, it would be interoperability, and it's interoperability that we believe will address that need. And so, from our perspective, what we've been working on and investing in and funding projects to flesh out and try and test and then bring to life is this notion of common standards-based information models, and that's where our work with Germany and the VDMA has been so helpful. If we think about scaling AI and machine learning, and Bruce nailed it on this topic as well, the only way we're going to see broad-based adoption of that is if we can build standardized semantic layers and object models, class definitions for process types, for equipment types, for asset types. And it's that effort, that standardization that we believe has to become a core competency for every technology provider, for every implementer, for every manufacturer. And that's, again, one of the core initiatives that we're trying to convene our membership to help them understand and then engage in this way.
Yes, Karen, please. Yes.
From my purview in the startup world, I've seen probably a handful of companies that are trying to leverage AI tools to be able to dynamically create data models for AI that take into context what kind of manufacturing process you have. If I go back to Ed's thing, you'll never have like a scalable solution if you get wedged in one of those particular boxes. So you're going to need solutions that span, and I'm at least somewhat gratified to see folks leveraging AI to try to address exactly this problem.
Great. So there's upstream a kind of, upcoming movement to adopt to be more flexible interoperability. Great.
Yeah, I think that's a great observation, and I think that's spot on. The thing that we have to change going forward is this very use case centric approach to solving a problem. Right? I have a use case today. It's going to solve this problem in my plant. I develop a stovepipe architecture from connectivity to information models to application. And then the next use case comes along and I have to build the whole thing from scratch every single time, right? Particularly for small and medium manufacturers, we have an opportunity to leapfrog that entire legacy technical approach by creating interoperable infrastructure that allows one common infrastructure. And Christoph Berlin and both Kevin and Christoph, Kevin from McKinsey and Christoph from Microsoft, had exactly the same approach, which was very gratifying, and exactly the same recommendations: common infrastructure, common data information models to drive multiple interoperable use cases. Small and medium manufacturers will never engage effectively if they're left to their own devices for every use case looking forward to solve this problem.
Okay, great. Yes. John, this is Janine. Really great job. Thank you. And love your last slide, taking the king for a day very seriously and putting a lot of recommendations down. So thank you for that. One of the things we're talking about, the complexity of, adopting and moving smart manufacturing forward inside of a company and inside of our country. What I found interesting on your slide is layers of complexity of, call it just the system outside of all that. So I'll point to companies not being aware of Manufacturing USA, right? That's a complexity. Then I read, if they do become aware, I read that there's difficulty and complexity in trying to maybe engage. I read complexity in your first number 2 bullet about the number of federal efforts that are confusing and counterproductive, maybe not aligned. So I think it's important to also really pull those out of what, I'm pulling those out, maybe not as the technical person in the room for what happens inside of the manufacturing process, but certainly can attest to what you're writing here. And one statement and then followed by the question is, we see companies really trying to figure this out. They come outside their four walls and they go into, call it the system, right, of all of us who are trying to help. And it is a very confusing place, as you've kind of noted here. Could you expand a little bit on maybe your last bullet that talks about dramatically reduce the effort, cost, and complexity of engaging Manufacturing USA, if there's an idea that you have specifically around that? But what I'm reading into that is, if people did understand, more understood Manufacturing USA existed, there's still the complexities of then that last bullet. Thank you.
Yeah, thanks, Jean. I think those are it's a great set of observations and a sort of Russian doll set of complexities that need to be addressed one layer at a time. I think particularly, the vast majority of manufacturers here in the US are not engaging with federal programs, federal funds on a day-to-day basis. And when they do reach out to CESMII, when we reach out to them, when they find us, we find them, there are immediate sort of, whether they're conceptions, preconceptions, misconceptions about what it means to engage in this kind of organization. There's that perception to be dealt with, and there's the reality of sort of the risk that comes with use of and engaging with federal funds. And even the basic idea of cost share. Most manufacturers have no idea what cost share is. I had never heard of the term before I came here, and it took me a long time to figure out the nature of cost share and how vital it was in this framework. And so those are risks, right? And then there's the risk of being audited, and large manufacturers can overcome a lot of that perception, misconception, that risk, but small and medium manufacturers struggle. And we need more than just the manufacturers that are engaged here because of project funding. We're thrilled to see our membership grow in our 5th year of existence here at CESMII, with very little to no funding left within our current award. But our membership growth is growing dramatically because of the work that CESMII is doing, not because of the federal funds. And it's but it's a heavy lift, right? Because of those complexities. So I don't mean to overuse that term, but thanks for bringing up that question. I think there are things that can be done to simplify our membership agreement, and then also to allow us to engage more effectively with other institutes where, for example, with CESMII or with MXD or with Rapid or with America Makes, we could be engaging with Lyft. We could be engaging in more constructive ways to solve problems together versus reinventing the wheel, which none of us have the funds to do and should be doing.
Thank you. I just in closing that,